Hey guys, we're going to do something a little bit different today. Normally when I do the machining videos, I just show you the end result or the end of the program once I've got everything figured out and dialed in, which is usually the interesting part, but today I'm going to show you the uninteresting part because it might be interesting to other people. So I'm going to take you through setting up the Tormach slant bed lathe. I'm going to change out the tools, get everything ready for that in that way, and then I'm going to go through how I'm going to program this, and you'll see all the failures or all the different ways that I have to try to do this, and maybe you might even learn something. I know I will. Alright, so I'm going to probably cut here and I'll show you the stock selection and talk to you about why I picked what I picked. Alright, so I didn't tell you the part that we're going to be making is the ram main body. Let's see, you got the drawing right here. I'll put that up so you can see even better on the video. And the outside diameter of this part is going to be 1/2 inch. So what we picked as far as stock is going to go is going to be a 9/16 rod. And that's so that we have some room to clean it up on the outside and get a nice machined finish. I could have went with 1/2 inch rod, but 1/2 inch rod means that we wouldn't be able to do any kind of cleanup on the outside to get a really nice even finish. So go for a little bit bigger rod and we'll machine it down. We're going to be using 5C collet today in the Tormach to hold the stock as it's getting machined, and we're going to leave it this 3-foot length, and I'll have to bring you around here and show you the little setup that we got to keep this from whipping and hurting me or anybody who else comes in here today. So I'll show you the setup of that and how to take the collet out, or how I take the collets out, and get on to setting up the tools. Okay, so we're about ready to put the new collet in, but before I put the new collet in, I always take a rag and wipe out the seat, just so that if there's any chips or anything, any kind of debris, it doesn't affect the accuracy or wear out unevenly. So just make sure that's clean, just make sure the collet's clean. And just slide this in, and we can just feel around. There's a pin that goes into this groove that keeps the alignment. So we just want to feel around until that pin slides into there. And then on the back side we can screw that draw tube by rotating the opposite way. Screw that draw tube into the collet. And sometimes it's a little bit tricky, it might not want to go right away. There it goes. Give it a little bit of a push. Now I can just screw this down until we get kind of close. There's not a lot of movement, and so we know we're getting close. Okay. Now I'm going to show you one of the little secrets that I found when I was doing that, when I started. I found that when you put a rod this small into this machine and you start spinning it up, it has a tendency to whip really hard back and forth when it's on the back of a long bar. So I went ahead and made up one of these things here, and what that is just like a bushing, so that it can plug into this draw tube and just kind of reduces the size of the hole that this thing can go through, and that will keep it from whipping back and forth too bad. That'll kind of keep it centered. Once you get the part all the way into there, you can pretty much just take this out. It'll be too short at that point to really whip it all, or whip enough rather to really be of any danger. So just got to pull this back out. for a minute here. Set that down. Get this locked back in. Okay, so according to our drawing, this part is going to have a total length of 2 inches. So we want to make sure that this length is 2 inches plus some clearance room, so that whenever we go to cut it off, we won't run into the chuck, or none of the tools will run into the chuck. So 2.5 inches sounds like a good place to start for me. So I'll just take our handy little stop here, put it up against here, and slide it out until it touches, and that's going to be good enough. We'll actually give it a little bit more for this first one, so that we can face it off and set our length on all the tools that we're going to have to put in. So I need to tighten this up a little bit until I call it locks properly. Give that a little bit more. Okay, so that's locked in good and tight there now. And we're ready to get on to setting up tools. So now we're going to, I always up my jog speed up to 100. I know where I'm going. So we're going to just come down here with tool number 5 that's selected right now. Let's change that to tool number 1. So we'll go T101. This is my master tool for length offsets and all that happy stuff. So we're going to come over here, come down, and we're just going to get kind of close for right now, and then we're going to input. Let's start out at 1000 RPM, hit enter, and we'll turn the spindle on. And now we're just going to move over until we kind of touch the end, and we can face it off a little bit. So you just want to take a couple thousandths so that we're cleaning up the end. And we just stop everything and tell it that this is our Z0. Now, this was something that I learned the hard way. So the first thing I want to do after this is back off the end and go to my cutoff tool, which is going to be tool 202. I'll move to a safe X, and then I'm going to move until I'm at Z-2 and just give an eyeball check and make sure that everything's going to come out okay. So that's close enough. And looking at everything, yeah, we're going to be fine. So that's a good Z0 for everything. So let's move back home. Alright, so that's the stock setup. Now, we still haven't programmed any kind of G-code yet, and this is going to be a multiple setup part. We don't have enough boring tools. We don't have enough boring tools to make all the features on the inside, because what we're going to do is we're going to have to spot drill this. Then I'll probably drill it out with maybe a 1/4 inch drill with a parabolic chip flutes. Then the next thing we'll do is we'll take a smooth finish 3 flute carbide drill and drill it out to 3/4. But knowing what I know about the O-rings that I'm going to be putting in here, I'm going to want to ream this to a little bit above 3/8 to about 380. So we'll ream that out to 380, which I have a reamer for. But that's 3 boring tools, and let's jump over to tool 6. So T606. So I only have a slot for 3 drilling or boring tools, and I'm not going to tear down the rest of these tools to do that. What I think I'm going to do is do the drill operation, the spot drill, rough drill, semi-finish drill operation on this setup, and turn the OD to 1/2 inch, and that'll be it for the first operation. The second operation is where we'll do the reaming and the boring and the threading, because that'll be another set of 3 tools that I need. So with that in mind, we'll go ahead and get on writing the program to do that stuff. Okay, so if you've seen a couple videos ago, I was talking about how I wanted to get this bench done. It's still not quite done, but it's done enough to start putting some of my tools in. So the short drawers here were specifically made to hold these drill bushings, and these are the blanks. This particular one is a blank to make things like this here. And what these do is these go into the holes in the turret. These are 3/4 inch holes, and they are split so that whenever you clamp down on them with these pinch bolts, you clamp onto the tool and hold it concentric, and you can use it to drill. So it's a little bit more rigid than using a drill chuck, but not quite as versatile. But I have plenty of these things here, and I don't want to you have to use all the extra Z clearance. Whenever you put a drill chuck on here, your Z home position for your tool change would have to be a lot further back. So I want to save a little bit of time by not putting any kind of drill chuck on here and getting the tool as close to the same length as possible. So okay, we got tool number 6 in. Tool number 6 is going to be our spotting drill, so that's already in there from the previous job. Tool number 7 is going to be our 1/4 inch drill. So we got that right here, and this is a parabolic drill, so that we don't have to worry as much about clearing chips. This can clear a lot of chips real good. So we need a 1/4 inch split, 1/4 inch collet here. So, and these are the kind of collets that I actually make these collets here. This is one of the first programs that I made, and I actually like to split them this way as opposed to this way. This is a different style of splitting. I think that this holds them better because the point that you're trying to bend is further from the center. Okay, so I'll put one of these things in, and we'll get started on that. So these are pretty easy to put in. You use the drill size that you want to have the hole be. Drill the hole so you know that it's going to be the right size. I don't bore these out or anything like that. I just use a drill, and slide that in there, and it registers up against the surface. And then I lose my wrench. Oh, here it is. So make sure this is going to be tightening, and then I can just tighten this down. There it goes, and that's it. So that's nice and tight in the little split collet. And what I'm going to do now is move this back, go to tool 7. and you can probably see kind of a little bit washed out, but I know that the center of this hole was bored whenever it was at X minus 15.97 from the home position. So I can just, I'm going to jump you over here to the computer and I can show you what's going on. Okay, so we got tool 7 selected over on the machine, and we want to make the offset for this thing here. So, alright, it's already set to tool number 7, which is a drill. It's shown as a center drill, but it works for any drill. And if we go to our offsets table, tool number 7, you can see the X is at minus 15.97, just like it's written on the holder there. So if I tell this thing to go to X0, that should center it on the part, and it did. So that's good so far. So far so good. And then I just take this little piece of Starrett shim stock. It's 11 thousandths thick, and I will just step over until I can touch off on the end of the part, and that way we'll know where we're at. Okay, so we got our 11 thousandths shim stock here, and we're just going to run over until we get kind of close. Then we're going to step in 1,000th increments, and we're just going to go until we start to feel it. Yep, there we go. See, it's touching a gentle push or pull. Keeps the stock right there, and then we can come over here and go to our touch Z and say 0.011. That'd be 111,011. Touch Z, and our tool is set. Okay, we're ready to do some programming. Now, because this is sticking out so far, I'm a little bit concerned about getting a taper because of the tool pressure when we're cutting from here to here. So what I'm going to do is I'm going to cut the outside profile first, because that's when the tool part is going to be the most rigid. And and on the last pass, we're actually going to do a little bit of handwriting of G-code, so that if there is any deflection from here to here, we can dial that out by making this cut at a taper or something like that, so that we can dial that taper right out of the part. So we're going to start out with the Wizards first, and first thing we're going to do is we're going to rename this to the part that we're making. It's going to be TJD 1024, and I know this is going to be, this is the first operation, so I always call it A. Now right now the max spindle RPM is going to be 2,250, and that's going to be too fast, because if you remember earlier in the video, we were talking about how the stock sticking out the back end of the spindle can whip. That's going to be a little bit too fast for my comfort, so we're going to just bring it down to 1,500 RPM, and that's probably even going to be a little bit much. We'll just do 1,000 RPM. We'll just be safe on the first couple go-arounds, and we can always ramp that up if we need to. So we're going to change our finishing surface speed, or finishing inches per rev, down to about 5. 5 is going to produce a good surface finish, I know that. 3 is something that I do whenever I'm cutting threads and I need it to be ultimate. 10 is going to be my roughing speed. This probably could be faster, but the higher this goes, the more tool pressure and the more likelihood that you're going to get deflection as it's getting cut. So I'm just going to leave that at 10 for now. That's a good safe number. So we want our final diameter to be 0.500, and our initial diameter is going to be 0.5625. Our Z end is going to be minus 2 point. We're going to go a little bit past so that we make sure that we cover everything with this surface finish. So that's going to be 2.05. Go 50 thousandths past. That'll be enough. And we're going to post to file, and we're going to do, this is going to be a paintball part. This is a WGP RAM, and we'll leave that right there. Now, the first thing, we know that we want to dial in that last pass. So what we're going to do is we're going to go straight into edit G-code, and this finish pass, we're actually going to take most of this stuff out. So we are going to be at, when this finish pass starts, we are going to be at coordinates x 5.3625, z 0.1. Okay, so we're going to be above the part and outside of it. So first thing we're going to do is we're going to G00 x do space x 0.500, and we're going to put a comment in here, adjust for end deflection, just for end deflection there. And then we are going to feed into the part, so we're going to G01 Z0. So now we are at the very end of the part, at half-inch diameter, and we're ready to go. So now, technically what I can do is just type in G01 Z minus 2.050, and that would be done. But what we want to do is we want to make sure we're setting up a potential taper. So what we're going to do is we're going to add an X 0.05 or 0.500, so that way we can adjust this number, which is the far end of the part, without adjusting our final diameter. So we're adjusting for end deflection here, and this will be the final dimension, which I know is going to be good because we're so much closer to the chuck, and we're up near more stock, so it's going to be more rigid. So I think this is going to be fine, but we'll just put in here end taper. And then what we're going to do is we're going to feed out of the part so that we finish it so we get a nice shoulder. So we're going to go G01 and X 0.6. So now we're outside of the part, but we still don't want to wrap it, or we don't want to go anywhere crazy just yet. Actually, looking at the code that the computer put out before, it's going to move to X point and then 0.1. That's a good place to be. Okay, so that looks good. And we'll keep our 5,000ths, 1,000. Okay, everything looks good. Now while we're at it here, we're going to add a little bit of information to the top. CRIP description of the part, and this is going to be RAM main body op1, and the tools that we're going to be using are going to be T101, and that is going to be a CNMG 432. And tool number 2, tool 202, is going to be a GTN-3 cutoff insert. And that's all we're going to need for the OD tools. Then we're going to go up to T606. This is going to be a number 4 spot drill, center drill. Tool number 707 is going to be a 1/4 inch parabolic drill. And tool number 808 is going to be a 3/8 carbide 3 flute smooth drill. Okay, so that's what we got for the first step here. And actually, we probably want to do a roughing, a surface this thing to length first. So, okay, we're going to change to tool 101, and then we are going to G00X0, or actually X.1, 0.10, and then we are going to G00 Z.030. And what this is going to do is this is going to run before the part gets put in, or before the part gets indexed forward. So what this is going to do is move to 30 thousandths in front of where the 0 is now, and stop and wait for me to index the part, index the stock out, and lock it in place. So we're going to M01. So that's going to be weight index stock. So we're going to index the stock there, and then we are going to pull back away from the part before we start the spindle and start the program. So we're going to G00 X or Z.1 G00 X.6. And actually what we're going to do is, since we don't really, it's not hard to write a facing code, so what I'm going to do is I'm just going to add the facing code in right here. So we're going to G00 Z minus, or Z 0.020, so that's going to be at 10 thousandths facing cut, and G01 X0, and then we're going to move out to G00 Z.1, and we know that there's going to be nothing there, but we'll do it in 2 steps. G00 X.6. So now we can just copy this and copy this part here and paste it in below, and all we have to do is change this number to 10, and one more time to let's see, 05. And then we are going to actually, we reduce the depth of the pass there just so that we make sure we get a good finish. And we're going to go like that, but we're also going to take this G95 and copy this into right above here, because we want this to be a finish pass. So we'll take this 0.5, so 5 thousandths per revolution. But we want to bring it back to 10 thousandths for roughing the OD. So we'll just copy this again, and before we start the next part, we'll change this back to 10. And we should be good to go. So that should be our facing and our outside profile. And this finish pass is going to let us adjust for any deflection. So let's save that. Yes, we want to reload. Okay, so here we go. Here's a good thing. Near line 6 of this part is, there's an unclosed comment. So Looks like probably up in here I forgot to close a comment, which right there it is. So close that, save it out, and we shouldn't get an error now unless I made another error. Okay, that's it. So you see the surfacing cuts, the OD profile cuts, and now we're going to move on to the drilling. So drilling's pretty easy here. We won't have to do too much craziness on this, but we do know we're going to go minus 0.25 with tool number 6, so that's our spotting drill. We know that. We'll start at 10 thousandths above, and let's slow down our feed for this. We want to go 5 thousandths per revolution. And we're going to keep our spindle speed at 1,000. And we're going to append this to the file this time. Append to file, and you can see that now we have end of OD turn, drilling G code generated, and that's our drilling G code for our spot drill. Okay, where was I? Okay, so we did the spot drill, and now we're going to do tool 7. So that's our 1/4 inch roughing drill, and we're going to go to a little bit less than what we want the drill depth to be for this finished drill. So the finished drill is going to be 1.610, so we'll do 1.6. And let's see, we want our peck depth, we want that to be a lot shallower than that. We're going to clear it every 1 diameter, or let's do it every half a diameter just to be safe, so 0.125. And again, we'll leave our roughing inches per rev, 5 thousandths, still 1,000 RPM, and we'll append that to the file. And last but not least will be our number 8, and this will be 1.610, and we'll bring this down to 0.25. So because it's already roughed out, we can probably go a little bit deeper than that even, but we'll go ahead and just let that start out there, and if we need to change it, we can change it. So we'll append that to the file, and we'll just look at the G code here real quick. Descriptions, right, okay, all that's right. We got a good one on there. Okay, we got our taper adjustment, our spot drill, rough drill, clearance drill, or finish drill, semi-finish drill, I guess, because we're going to ream this afterwards. So we're going to save that, and everything looks good. Okay, so everything looks good. That looks like a good place to start. So now we want to set our G30, which is our tool change position. So what we want to do is we want to just look at the lengths of all the tools here, and we say that tool number 8 here probably sticks out the furthest, and so we want to get to tool 808 and then just make sure that we're, say, an inch beyond Z+1 beyond this, so that way we can, whenever we change tools, we know that we'll always clear. So we'll go T808. And you see right now it says Z2.4, so we're going to take our Z and we'll just make it, that's close enough. We'll set our G30 there. Okay, so I already adjusted the coolant and everything like that, so we know that the coolant's going to get on the tool where it needs to be for all the tools. So we're going to give this thing, close this thing up, and Hold on a second here. I'll be right back after I clean the window. We'll close this up and give it a run and see what happens. Okay, so we got the window cleaned off. We got everything set up. We're ready to try our very first run. Hopefully there's not too much glare for you guys. I had to keep the window closed because it's going to make a mess whenever it starts, coolant starts. But everything's ready. Let's wish us luck. I hope we don't crash anything. So this is our very first. It's waiting for me to index the stock forward, so we're going to do that. Next is going to be our taper, the beginning of our taper. And what we're going to do is, before this actually, when it finishes its cut, I'm going to do a feed hold and get in there and measure what the two ends of the part are, just to make sure that we are where we need to be. Alright, here we go again. So we're going to recut that first thing, so we're going to cut mostly air, but that's okay. We're just dialing the program in for now. So let's go. Okay, so that's to set the facing size, which we already did, so we're just going to hit cycle start again. I feel like we could probably go a lot faster here on this outside diameter move, and at least on the first couple ones, and then we can finish with our slow feed rate. But it looks like we're just wasting time. So we'll just have to remember that, and whenever we go into the final tweaking phase of the program here to cut time down, we'll remember that can go faster, and we can change that in the G-code. So now we're going to go home. We're going to get to our spotting drill. That was a pretty deep spot. Maybe we'll have to change that. Here's going to be our roughing drill. With the parabolic flutes, I don't have any problem going this deep. With a standard drill, though, I'd be a little bit worried right now. And again, because we have clearance on this one here, I'm not too concerned about it. Plus it's carbide, so it should stay pretty straight. I feel like the chips that are coming out of there look pretty good. They're not too thin, not too thick. So that's probably a good feed rate for both of these drills. And now that's actually the end of the program, because we didn't want to cut this off until we were sure that it was going to be good. So everything looks good, so we're going to go back over the computer, we're going to tweak some of those feed rates and add the cutoff program. Okay, so that was pretty successful. So now all we got to do is cut the part off, and it will be, the first operation will be done. So we're going to go to groove part here, and we're going to go to part, and we're going to give our Z dimension at 2.005 minus 2.005, and that 5/1000 is so that on the next step we can just clean that up and make the end look good. Again, we're going to go about 1,000 RPM, and our inches per rev is only going to be 1,000th. But since this is the last part, and this is one of the more fragile tools, the GTN3 insert, now is not the time to make up any time. So we'll just let this go, and let it take as long as it's going to take. It's still going to be pretty quick. But okay, so now we're ready to append this to the file. Append to file. We're good to go. So now we have a cutoff. Back here it's shown, and we're going to go into the file, and remember we mentioned earlier that we're probably wasting time on this front section, so we're going to leave the facing at 10,000ths per revolution and the finish at 5, but we're going to up the actual roughing to 15,000ths per revolution, and we're actually going to leave this still at 5. So our finish depth on this guy here was pretty deep, so let's just change it to 0.200. Actually, that's the dwell 250. We'll leave that quarter of a second dwell at the bottom to clean everything up, but we'll only go 200 deep on the spot drill, the center drill. Drilling G-code, that was okay, I think. But since it's the roughing pass, and I have no problem with the parabolic, let's go up a little bit faster. And again, we can go a little bit faster on the other drill too. That'll get us where we need to be. So let's go ahead and save that. Close it out, reload. So you can see this was 3 minutes and 15 seconds to do that. We're not going to make you watch 3 minutes and 15 seconds of mostly cutting air. So I'm going to go ahead and finish this one off, and we'll start you fresh on a new one after this gets cut off, and you can see the whole program start to finish. Okay guys, so the prototype part there, the very first part, just came off the lathe. It looks pretty good. I'll show you a picture of it here towards the end. But all I did was pick the part out and clean the window, so you can see how this program is going to run now. So you see the stock is pretty far back, and everything's closed. So all right, we're going to hit cycle start, and we can watch the whole thing. So this is where we index the stock forward. We can just push it in from the back till it touches. We could feel that on the other side, and then lock the collet, and away we go. see how much faster that 15 thous per revolution is than the 10 thou. It's only 5 thousandths per revolution, but it really makes a difference. If you remember, we kept this at 5 thou per rev so that we don't have too much tool deflection of the part, and we're going to get a good size. Of course, we're going to double check this once it comes off the machine, but I'm pretty confident that that's going to work out good for us. So we're saving a little bit of time on the next two drill ops by going to 7 thou per revolution, and I think that's going to be fine. Yeah, looking at the chips coming out of there, no problem at all. Probably go even faster, but I don't want to push it. The worst thing we could do is break a drill off halfway down there. Hope you guys can still see that. Making a little bit of a mess now with the coolant. So I don't know if you can tell, that's again 7 thou per revolution chips. Those chips again look a little bit heavier, a little bit more robust than the 5 thou per revolution chips, but they're still looking good. Again, we probably don't have to break the chips as often as we are, and we could probably go a little bit, feed a little bit harder, but this is the only one of those drills that I have, so conservative is okay. Here's our final cutoff. Again, this is 1 thou per revolution, just because now is not the time to make up any time on the part, because these inserts are pretty fragile. We don't want to break one off and break the insert, and we could potentially lose the holder. Done that before already. So there we go, part dropped off down the bottom. Goes back to home. We can pull this part out now. Still got some coolant on it, but let's give us a second here and we'll take a measurement. Okay guys, we're going to take a quick measurement on the ends of this part here to see if we're within spec. Moment of truth. 5.026. It's a little bit big. How about on this end? 5.024. Okay, so again we're within 2/10 of being perfectly straight, so there's only a 2/10 taper along the length, which is good. So I'm just going to go in and reset that one, reset the X position again on tool number 1, just to try to get a little bit closer, but 2 thousandths isn't going to stop us. That's still a good part. Alright guys, hope you enjoyed watching that. This is a part from nothing to finish, and I think we got at least 3 or 4 more setups for this thing, so maybe I'll just take everybody along for the ride on this one, and you can see how this entire part gets made and see what all the things that have to go into just making a little tube with some threads in it. Alright, see y'all in the next one.